Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the homework for yesterday. So here is the formulas. The formula for the volume of any pyramid or cone. We looked at this on Monday, where we took Ben and I took water and filled up a cone, and then poured it into a cylinder that had the exact same height, the exact same base area, and it went up exactly 1/3 of the way. And so this showed us that the volume of the cone with the same base area and the same height as the cylinder would have 1/3 the volume. And so that becomes our base formula for all pyramids and cones. And your task is to figure out, what is the base? Is it a triangle? Is it a rectangle? Is it a circle? What are the formulas for those bases? Now, this particular base here, this is a pentagonal pyramid, and we don't have a formula for a pentagon, although you could figure out the area by dissecting this into two recognizable parts. There's a triangle here, and there's a trapezoid there, and if you knew those measurements, you could figure out what the base area is. But almost always in a situation like this, they're going to tell you what the area of the base is. We are not, in 8th grade for certain, going to require you to figure out the area of a more complex polygon than a trapezoid, or rectangle, or triangle, or circle. So same idea for the volume of a cone. A cone has the same attributes as a pyramid. It just has a circular base instead of a polygon base. And so the cone is going to be always 1/3 of whatever the base area times the height is. And in this case, this is actually easier because the area of the base is always a circle, which will always be pi r squared, no matter what. Here, the base formula can change depending on what the polygon is for your base. All right, well, yesterday's lesson was about the sphere. So let's go ahead and write down that volume formula for the sphere that we figured out, or I figured out and shared with you. You're welcome. Is 4/3 of pi times the radius cubed. So in each one of these situations, we need to know, all right, what's the radius? Here it's given as 5, so it's going to be 4/3 times pi times 5 to the 3rd power, which is 125. So we would typically multiply your 125 times the 4, because this is going to be 125 over 1, right? Times your 4/3. And then once we know what that is, then go ahead and multiply it times pi. So I don't believe we can simplify anything here. This ends up being 500 divided by 3 times pi. And so 500 divided by 3 gives you that number. Now multiply that times 3.14, and you'll probably get that. But if you multiply times pi, a little bit more, but still pretty close. This would technically round up to 524. This rounds down to 523. They're within 1 cubic centimeter of each other. Technically, they're within 3/10 of the cubic centimeter, so that's a pretty good answer. Now, just for clarity's sake, if I did take the 500 divided by 3 and got that number, then multiplied times 3.14, which is the rounded off version of pi, that is why I have 523.3 repeated, because I used pi as the rounded off version, 3.14. So I'll do the same thing here. In this case, however, we don't have the radius yet. We have to take half of that, so the radius is 1.5. So we're going to take 4/3 times pi times 1.5 to the 3rd power, and I'm not sure what that is off the top of my head. So 1.5. Here, look at that. We got a button for raising to the 3rd power. To the 3rd power is 3.375. Now multiply that times 4/3, which is not really easy to do. So I'm going to multiply it times 4, then take that answer and divide it by 3. And there is 4.5. So we're going to have 4.5 times pi. And let's see if I don't get this as my answer. by taking that times 3.14, and that is precisely what we get for my answer. But if you had done 4.5 times pi, you get something a little bit bigger, 14.137, which rounds up to 0.14. But if we rounded it to the nearest tenth, either one of them are just going to be 14.1. So either one are fine. If the volume of a sphere is 113.04 cubic feet, write and solve an equation to find the radius. Okay, so now we're in a situation where we know what the volume is, so we're going to plug this in for V, but we have to solve for R. So to do that, we have to start by multiplying what is 4/3 times pi, and then that's a number that's going to be multiplied times the R cubed, so we'll have to divide it on each side. So let's figure out what that is first. 4 Let's do 4 divided by 3 equals that. Multiply times pi times 3.14 gives you that. And now that's the number that needs to be divided away. And that's going to be a little, I'm going to have to round that off. But we'll probably end up having something really close to 27 here. So let's divide each side by 4.186 repeated. Divide this by 4.186 repeated. And I'm going to actually do this. Let's clear this out. I'm going to take 113.04 and divide it by 4.1866666. And I'm just going to keep going with that because it was 0.6, the 6 repeated. So this is going to give us a pretty accurate answer. And the answer is that right? I don't think that's right. What did I do? Oh, I got 4.866. I didn't get the 1 in there. See, I'm expecting it to be 27. So this is one of those reasons, where you can make a mistake if you don't show any work and you don't understand why you didn't get the correct answer because you didn't copy anything down. Here I can see I punched the wrong number in the calculator. So let's try this again. 113 and 4/100 divided by 4.18666. Okay, this should give me 27 for my answer. It does. So that means that R cubed is equal to 27. So the cube root of 27 is going to be whatever number you could repeatedly multiply 3 times to give you 27 for an answer, and that is 3. So this particular sphere with this volume had a radius of 3 feet. All right, find the volume of each of these shapes. Well, the volume formula for this is take the base area and multiply it times the height. And in this case, it doesn't matter what our base area is because it's a rectangular prism. If we want to make that our base area, we could, or we could make this our base area. Doesn't make any difference. So I'm going to go ahead and make this the base area and say 20 times 7 is 140. Right? 2 times 7 is 14 with the 0 there, 20. And then multiply that times the height. So this is the base area times the height of 9 gives you 1,260. So the volume of this, if we were to break this up into a bunch of cubic meters, there'd be 140 cubic meters in this first layer. And then we have a total of 9 layers going up for a total of 1,260 total cubes in this box. And now we've got our rectangular based prism, but this is, or pyramid, but with a pyramid, it's not just base area times height, it's 1/3 the base area times the height. And so in this case, our base area has to be on the bottom because it's a pyramid. So we're going to take 22 times 12. Ooh, you know what I want to do? Hold on for a second. Let's just plug this into the formula. Volume is going to be equal to 1/3 times the area of the base, which is 22 times 12, right? That's the base area, times the height, which is 18. I'm going to choose to take 1/3 of 12 right now and make that 4, so this becomes 88. 22 times 4 is 88. So now all I have to do is 88 times 18, which I'll happily do 88 times 18 in my calculator and get 1,584 cubic centimeters. Okay, so key here, remembering that when you're dealing with a pyramid or a cone, they are 1/3 the size, that's 1/3 the volume of their respective prisms and cylinders. Here is a prism, it's not a pyramid, so this would be the basic formula for finding volume of prisms. All right, make a table for the rule y is equal to 2x cubed. This is an example of a cubic function. And if you recall, when we had linear functions, they formed straight lines. When we had quadratic functions, where you had an x squared, it formed a parabola, which could either be open up or open down, depending on this number right here in front of the x squared, whether it was a positive or negative. Now we've got a cubic. The cubic shape looks like this, or looks like this, depending, once again, on whether there's a positive number there or a negative number there. Since ours goes in the positive direction, right? It's going up as it goes from left to right. That means there was a positive number here being multiplied times the x cubed. You'll get more into that in high school, understanding why the shapes are the way that they are. So anyway, we take, and they gave us these as our values for x to plug in. And so we're going to cube those numbers and then multiply them times 2. And this is our output. And then you just plot a bunch of those points until you get the general shape of your graph. That's what your graph should have looked like. Sarah and her 3 friends had left her house for a long bike ride on the river bike path. They rode for 3 hours at 10 miles per hour, which means they must have gone 30 miles, right? I'm going to underline that. Oops, I changed. Yeah, let me do this color. So that's 30 miles, and then rested for an hour. After lunch, they raced each other back to each other's house at 15 miles per hour. And since they're 30 miles away from their home, if they went 15 miles per hour, that means that would take 2 hours for them to get back home, right? Because 15 times 2 is 30, just as 3 times 10 is 30. So setting up our graph where the time is our x-axis, that's what we have control over basically here. And the distance, technically, we don't have control over either one. You could reverse these, but they did say have the time be on the horizontal axis. So time is serving as our independent variable. And so here she is at home, and if she's going 10 miles per hour, right? 1 hour is 10 miles, 2 hours is 20 miles, and after 3 hours, she's 30 miles from home. Then she spends an hour going nowhere. Time keeps moving. You can't stop that. But your distance can stop. So it's not going up or going down. And now this looks like a negative slope, but that's just perspective. You're coming back home now. So in 1 hour of travel, that was 15 miles. And then a second hour gives you a total of 30 miles. So for the first 3 hours, she's going, showing linear growth at a constant rate of speed of 10 miles per hour. Then she stops for an hour, and then the last 2 shows a constant linear kind of decrease of 15 miles per hour. And so technically, I guess if we're talking about slope ratios, this would be a negative 15 slope, and this would be a positive 10 slope. But the positive and the negative doesn't really mean a whole lot in this context. Okay, and I think this might be the last problem. I'm not really sure. What are the Charisse can fill lemonade cups at a rate of 4 cups per minute. So that's a unit rate, correct? So if it's 4 cups in a minute, that it would be 8 cups in 2 minutes and 12 cups in 3 minutes and so on and so forth. So basically, we're just going to say 4 over 1 is equal to how much over 6 minutes. And you can see what your multiplier is going to be. You multiply the 4 times the 6, and you're going to get 24 cups. Do the same thing. How many cups in 10 minutes? Your multiplier is going to be a 10, so 4 times 10 is 40. This would be the equation that we would use here, where the amount of time affects the number of cups that she can fill, right? So the more time that she spends filling cups, the more cups she's going to fill. And it looks like it's 4 cups per minute. And if she spends no time filling cups, she will fill no cups. So that's what makes this a proportional type of relationship. So this ends up being the equation that would fit here. So I could use this equation now, and I can still use these proportions as well. I don't just have to use this equation. But if we want to find out how long it takes for her to fill 100 cups, then we just have to fill that in for C. And now we know it's a division problem. 100 divided by 4 is 25. So the time would be 25 minutes. So you could solve it proportionally or using the equation. And this has got to be the last one, right? Yes, that's the last one. Okay, so what do we have going on here? This is the not triangle sum theorem. This is the exterior angle in a triangle kind of theorem, where this angle here is supplementary to this angle here. And since they're supplementary, that means that their combined sum is 180. The three angles inside the triangle also add up to 180. So x has to be equal to the sum of these two numbers. Since x plus this number equals 180, and this plus that number equals 180, meaning x has to be equal to the sum of those two numbers. So you add 38 and 90 together. This must be 128 degrees. And if that's 128 degrees, we can test it. This one's going to have to be, I think, 52 degrees, right? Those two add up to 180. Now let's add that to these two, and they add up to 180 as well. So yes, that means our exterior angle must be 128 degrees. And in this situation, you've got two parallel lines that are being intersected by a transversal. So that means that this angle matches this angle matches that angle. They're corresponding angles. These are alternate interior angles, and it looks like x has to be supplemental to the 82 degrees, since this one right here is 82 degrees, being alternate interior angles. So if these two are supplementary, then we're going to take 180 minus 82, that's 180 there, and you get, let's change that to a 17, change that to a 1, this is an 8, 17 minus 8 is 9, so this angle must be 98 degrees. All right, so why don't you go ahead and head over to that check for understanding, give you a little bit more practice on figuring out how to find volume of spheres. And then tomorrow there's definitely going to be an assessment for you to show me that you understand the basics of how to find volume of cones and pyramids and spheres. All right. Thank you for joining me for the homework.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling